Good morning, everyone. Today we're looking at Unit 4, Lesson 5, Angles on the Cartesian Plane. So far in this unit, we've looked at angles inside of a triangle. And in a triangle, no angle can be equal to or greater than 180 degrees, right? And the sum of all the angles is 180 degrees, no more. Well, this is not the case when an angle is drawn using an XY plane or the Cartesian plane. So that's what we have below. The plane is divided into 4 quadrants. By the X and Y axes. So you can see here we have our x-axis, which we should be familiar with from graphing, and we have our y-axis. And so if we were to split this into quadrants, we start with quadrant 1, where our x values are both positive, and then we move in a counterclockwise direction for our quadrants. So quadrant 1, quadrant 2 is where our x's are negative but our y's are positive. Quadrant 3 would be x and y are both negative, and quadrant 4 would be x is positive and your y's are negative. All right, and if we follow that round, think in terms of a circle. As we go from quadrant 1 to quadrant 2, we can make up to 90-degree angle in there, and we're going to look at what that means. And if we continue on, we could make that, so if we go from here to here, that's a 90-degree angle. All right, if we go from that 90-degree arm all the way down to the next part of the x-axis, now we have another 90, so that's 180 degrees. And then if we continue that around to the negative part of my y-axis, so we have 90, 90, and 90, so now we've made a 270-degree angle. And if we continue on back to where we started, should make sense that we've created 360 degrees now, which is a full circle. All right, so an angle is defined using 2 rays, with each ray connected as a fixed point, or what we call the vertex. So we're going to look at what this means in this little graphic below. But the first ray is called the initial arm. And the second ray at the end of the angle is called the terminal arm. All right, an angle is in standard position if the vertex of the angle, remember the vertex of the angle is just a turning point on a graph. So if the vertex of the angle is at the origin and the initial arm lies along the positive x-axis. The terminal arm can be anywhere on the rotational angle. So let's look at this. So our initial arm can be seen if we look at this angle here. Here's my initial arm. So that's the arm of the axis, or the ray of the angle that lies on our x-axis. All right. Our terminal arm is our second ray. So those 2 rays form our angle in between them. Okay, and this ray, the second ray, or the terminal arm, can lie anywhere on the rotational angle. So I'll erase this, but that means I can have my terminal arm be here in quadrant 1, it could be here, it could be here, but straight, right? It could be here. So anywhere along that rotational point of our vertex, we can have that terminal arm. Okay, we won't keep all those there, that's just to show you. And then this is the standard position. We're going to look at some other angles that are made up of this basic standard position and kind of how that changes as we move from quadrant to quadrant. But that's the idea behind drawing these angles on a Cartesian plane. So let's look at some more to this. So angles on the XY plane are comprised of 2 angles. The principal angle is the first one. So the principal angle is the angle between 0 and 360 degrees. So let's say I wanted to do, or draw on here, a 300-degree angle. Well, I know that I have 0 degrees at my positive side of my x-axis, and then I have 90 degrees, 180 degrees, 270, oops, not 260, 270 degrees, and then back around to 360 degrees where I started. So if I want to draw an angle at 300 degrees, I'm going to draw my initial arm right at my x-axis. So that's going to be the start of my angle. And then I'm going to rotate until I can draw what would be approximately 300. So I go past 90, past 180, past 270. I don't want to get all the way to 360 because that'll be past 300. So I'm going to say somewhere like there. I'm going to draw my terminal arm. So I have my initial arm and I have my terminal arm. And we can say that this principal angle is 300 degrees. All right, so that's the angle that was the principal angle that we're drawing. The other angle that we can reference here is what we call the related acute angle. Okay, and this sometimes is called our reference angle, or reference. You'll hear those kind of used interchangeably, but either's fine. So the related acute angle, or your reference angle, is the acute angle formed between the terminal arm and the closest part of the x-axis. So let's just highlight that again, that's a lot. So the related acute angle is the angle formed between the terminal arm and the closest part of the x-axis. So it's always going to be positive and it's always going to be acute. So positive and acute. So if we look at this example here, we have 300. Well, this is my terminal arm, right? The second ray we draw is our terminal arm. So between my terminal arm and the closest part of my x-axis is going to be my related acute angle. So I'm just going to, let's figure out what that is. If we went all the way to 300, how much more would we have to go in order to get all the way around to 360? Well, I'd have to go another 60 degrees. Okay, and this is our related acute angle. Or we might call it RAA for short. Okay, so some things to recognize about our related acute angles. They can be in quadrants 2, 3, or 4, right? If we're in quadrant 1, we already have a positive acute angle, so it's not a related acute angle. If an angle is in quadrant 1, the principal angle and the related acute angle are the same. But what about if we are in quadrant 2? So let's say that we had our principal angle in quadrant 2, something like this. Right, so I'm going to call that P for my principal angle. Well, how do I find my related acute angle? Well, my related acute angle is going to be here. So the question is, how would we calculate that? I'm going to label these axes again, so we just remember what degrees fall on them. Right, so we have 0, 90, 180, and 270, back to 360. So if my principal angle is falling somewhere between 90 and 180, how do I find my related acute angle? Well, to find my related acute angle, that's going to be equal to 180 degrees minus P, or minus our principal angle, right? Because if I have 180 degrees to get all the way there, but I've already taken up some of that with my principal angle, I can find that by doing 180 minus that. If my principal angle was in the third quadrant, so let's just actually, before we do that, let's label our quadrants again so we remember. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we remember when I'm saying quadrants where I'm talking about exactly. So if we had our principal angle in quadrant 3 like that, I'm going to call that my principal angle. Well, our related acute angle is made, again, with our terminal arm and the closest part of our x-axis. So that piece right there would be my related acute angle. Well, here now my principal angle went all the way to 180 and past it somewhere between 180 and 270. So when we're in the third quadrant, our related angle is going to be equal to our principal minus 180. If my principal was, let's say, 220, I have to take that 220 and subtract 180 from it to figure out what's my related acute angle. Then we're going to do one more if we're in quadrant 4. I'm just going to draw it on another diagram because that one's getting kind of crowded. So now if my principal angle is in quadrant 4, so let's say I go all the way around to here, something like that, and that's my principal angle. Well, we saw that actually in the first example, my related acute angle is going to be in here. So the closest part of my x-axis is all the way back around to 360. So now if we wanted to find our related acute angle, we're going to take 360 and subtract the principal from it to find that related acute angle. All right, so that's just understanding that related acute angle is always the positive acute angle that falls between the terminal arm and the closest part of the x-axis, wherever that might be, depending on the situation. And we'll look at some examples of that in a minute. But some other things to consider when we're talking about angles on a Cartesian plane. Angles can be positive or angles can be negative. So a positive angle is formed by a counterclockwise rotation. And you'll notice all of the angles we've drawn so far have gone in a counterclockwise rotation. A negative angle is formed by, as you could imagine, a clockwise rotation. So let's say that we draw our terminal arm here on our x-axis, or sorry, our initial arm. And then if we wanted to draw our terminal arm somewhere up here, okay, if we went from our initial arm to our terminal arm this way, then we would say that theta is a positive angle because we rotated counterclockwise from our initial arm to our terminal arm. If we wanted to look at it in terms of a negative, if we drew our initial arm again along our x-axis, and then we rotated in a clockwise rotation, somewhere over here, let's say, is our terminal arm. So we went from our initial arm clockwise to this terminal arm, then we'd say that theta is a negative angle. Okay, so let's take an example of actually drawing positive and negative angles. All right, so sketch each angle in standard position and label the principal and related acute angle. So if we had 130 degrees, I'm just going to one more time label. I think we probably all know where they are by now, but where our degrees fall on our Cartesian plane. So if we were drawing 130 degrees, we're going to start with our initial arm at 0. We're going to go counterclockwise because it's positive, past 90 to 1. We don't want to go quite to 180, but somewhere between. And we'll draw our terminal arm. So we can say 130 degrees, and we can even label that our principal angle. Now our related acute angle is going to be the distance between our terminal arm and the closest part of the x-axis. So in the second quadrant, we said that to find our related acute angle, we're going to do 180 minus our principal angle. So a related acute angle is going to equal 50 degrees in there. Okay, let's look if we have a negative angle. So if we have a negative angle, we're going to start at 0 and we're going to move in a negative direction, 280 degrees. And you have to think about this. If I label these as 0, 180, 270, and 360, well, now I'm going negative, so I have to think about where I'm going to land. So I have my initial arm at 0. I'm going to go negative 90. Another negative 90 is 180. And then another negative would be 270. So I don't want to go all the way to that y-axis, but somewhere between there, we'll have our negative, we'll say that's a negative 210 degrees. Okay, our principal angle always has to be a positive version. So our principal angle is going to be the positive version of that. So our principal angle will be from that initial arm to the terminal arm in a counterclockwise position so that we can say the principal. So the principal angle. If we think about 210 negative, well then the positive is going to be 150 because 210 and 150 will make 360. If we want to identify our related acute angle, again, we're in our second quadrant, so our related acute angle is going to be 180 minus that principal angle of 150. That's going to be 30 degrees for our related acute angle. Okay, so we're going to look at it a little differently now where they're going to give us the angle and we're going to have to determine what is your related acute angle. So determine your principal, or sorry, they're going to give us our related acute angle and we're going to determine our principal angle. So determine the principal angle for a related acute angle of 45 degrees in quadrant 3. So let's make sure we know where we're putting that. We'll label our quadrant. So we have quadrant 1 starts there and then it moves counterclockwise for the other quadrants. So we have a 45-degree angle in quadrant 3. So there's my quadrant 3. All right, and it's a related acute angle. So that's the angle made with a terminal arm and the x-axis. So we're going to have 45 degrees there. Let's do that again so it doesn't look like 450. All right, so if I'm looking at this, I want to see what is my principal angle. Well, I'm going to have to start with my initial arm along the x-axis, and then I'm going to have to follow that all the way to my terminal arm. So remember, in quad 3, our related acute angle is equal to our principal angle minus 180. So this is in quad 3. So in this case, my related acute angle is 45. We're trying to determine our principal angle. Let me principal minus 180. So I'm going to add 180 to the other side. It should be 225 equals our principal. So you can see this is 225 degrees. Okay, let's look at another example. So now we have a related acute angle of 20 degrees in quadrant 2. Go ahead and put that on your Cartesian plane and see if you can determine what is the principal angle. Okay, so here's the solution to that. So if we draw the 20 degrees in quadrant 2, then we know that our related acute angle in quadrant 2 is 180 minus that principal. So if we plug that information in, we can determine that our principal is 160 degrees. And you can probably start to look at these and see, okay, if my related acute angle is 20 degrees, then I can see that that whole angle there is going to be 160 because 160 plus 20 is going to equal the 180, which represents half of that Cartesian plane. All right, so that's the idea behind principal angles and related acute angles. We're also going to take a look at some special triangles today in order to help us solve some of these angle questions on a Cartesian plane. So we have two triangles here. Use Pythagorean theorem to solve for x in each of the following triangles. So in this green triangle, if we want to find x, we got to remember that Pythagorean theorem is a squared plus b squared equals c squared. All right, so c is always our hypotenuse. It's always that side across from the across from the right angle. So 1 squared plus 1 squared is 2. So we're going to take the square root of both sides. So c is going to equal radical 2. And really, because we called it x, let's change those c's to x's. Just so there's no confusing. In the standard form, it's c squared, but we labeled it as x squared. So x is going to equal radical 2. All right, if we look at our other triangle here, same idea, where we have Pythagorean theorem, but now our x is in one of the legs. So it's going to get plugged in for one of the legs instead of for our c. So we'll say 1 squared plus x squared equals 2 squared. And we can square those. So 1 plus x squared equals 4. We'll subtract 1 to the other side. So x squared will equal 3. And finally, we'll take the square root. So x will equal radical 3. Okay, so there's something important about these triangles. First of all, this green one, we should be able to determine if we have legs that are the same size, then we have an isosceles triangle, and that should tell us that our angles opposite those legs are the same measurement. Since we already know one of them is 90, then these must be 45 degrees. Because they have to be equal, right? And we only have 90 degrees left in that triangle. Our other triangle here, we found that this leg is radical 3. All right, so if we know that this side, this one leg is 1, and our hypotenuse is 2, well, that means our angles have to be proportional the same way. See how this side leg is half the length of that hypotenuse? So that means that our angles are proportional to that. So the angle opposite 1 is 30 degrees, and the angle over here is going to be twice that, or 60 degrees. All right, we could draw this triangle another way as well. So if we wanted to draw it standing up essentially, and say that this is our 60-degree angle and this is our 30-degree angle, we just have to make sure that we put our sides in the proper spot. So notice where our sides are in that triangle relative to those angles. So opposite my 30-degree angle, I have that leg of 1. So I'm going to do the same thing. If I draw it sideways, I got to move the legs too. The radical 3 is opposite that 60-degree angle. And our hypotenuse stays our hypotenuse at 2. All right, so these are just some special triangles, and we'll put over here that this x was equal to radical 2. So there are certain special angles that occur quite frequently in everyday situations. Those are kind of the angles we see the most. So 0 degrees, 30 degrees, 45 degrees, 60, and 90 degrees. You are expected to know the exact values of the trig ratios for these angles. So if you can see in these triangles, we have 30, 60, and 45. We're going to get into 0 and 90 on another day, but using these special triangles, we should be able to figure out our sine, cosine, and tangent ratio for those if we memorize these triangles. So let's take a look at what I mean. So here it's asking you to determine the exact value for each trig ratio. So just because we're on another sheet, let's just draw those special triangles one more time so that we can kind of have them right with us to compare. So we had 45, 45, and those had a 1, 1, and a radical 2. That was one special triangle. And then the other special triangle is what we call a 30, 60, 90. So we had a 30 and a 60, and opposite our 30-degree angle was 1, opposite our 60-degree angle was 3, and our hypotenuse was 2. So I'm going to just work through the sine ones, and I'm going to pause and get you guys to do the rest. So remember that sine, so think that our sine ratio is our opposite side over our hypotenuse. So that's what we're looking for when we go to determine these ratios. So the sine of 45, if I'm looking at the sine of 45, I want to look at my opposite side over my hypotenuse. That's going to be my sine ratio. So my opposite side is 1, and my hypotenuse is radical 2. I'm going to do the same thing with the sine of 30. If I look at my 30, opposite angle 30 is 1, and my hypotenuse is 2. And then I'll do the same thing with 60. Opposite angle 60 is a radical 3, and the hypotenuse is 2. Go ahead and pause this and finish filling this out for the cosine and tangent as well. Okay, so there you go. There's the rest of the ratios filled in. Just some things to kind of take a look at. You'll notice that if you compare your sine and cosines for the 30 and 60, because remember those are coming from the same triangle, just different angles within that triangle, you can see that our sines and our cosines are the same. So the sine of 30 is the same for the cosine of 60, and then vice versa. The cosine of 30 is the same as the sine of 60. So those are the same. And then if you look at our tangents, you can see that these are just the flipped version of themselves. And that should make sense because we're just looking at a different angle in the same triangle and pulling one side length and then the other and then kind of flipping that scenario. So we're going to kind of put together all those things we've looked at today. We're going to determine the exact value for each expression. So you're going to be given a principal angle that is bigger than 30, 45, or 60. But once we determine the related acute angle, that will tell us what is those primary trig ratios, or in particular, which ones they're asking for each of those angles. So let's take a look at this. So determine the exact value for each expression. So the cosine of 150. So again, for the cosine of 150, we should be thinking A over H, right? I know that my cosine ratio is adjacent over hypotenuse. So let's first draw the principal angle of 150. Where is that going to fall? So principal angle of 150, we're going to go from 0, 90, not quite to 180, somewhere between 90 and 180. And we'll draw my terminal arm there. So this will be 150 degrees. So that was step one. We drew the principal angle, and now we need to state the related acute angle. So in here is my related acute angle between my terminal arm and my closest part of my x-axis. So we could calculate that. Hopefully we can see that that's 30 degrees, right? So we're at 150. To get all the way to 180, we'd have to go another 30 degrees. So I'm just going to draw a triangle from my terminal arm and see if I can recreate those special triangles we were talking about. So if that's 30 and that's 90, then this other angle is 60. So remember, in our special triangle, across from our 30-degree angle, the side length is 1. The side length across from 60 is a radical 3, but check what quadrant we're in, right? We're looking at our x values here. So my x is going to be a negative radical 3 because we're on our negative x-axis. And then our hypotenuse is always positive. So that's still going to be 2 because that's that special triangle we looked at. So let's first fill out part B. It says state the related acute angle. So that's a 30-degree angle. Now it says state the cosine of the related acute angle. So if we're looking at the cosine of 30, that's going to be my adjacent over my hypotenuse. So again, we're looking at the related acute angle of 30, which is going to be my adjacent side over my hypotenuse. So in that case, the cosine of the related acute angle is a negative 3 over 2. That is the cosine of whatever angle they gave you, and you're going to take that sign with you. So the cosine of 150 is going to be a negative radical 3 over 2. All right, let's try one more together, and then I'll get you guys to try one. So we have the tangent of 225. So we're going to start by drawing that principal angle. Draw that a little straighter. All right, so 225, we're going to start at our terminal, or our initial arm at the x-axis and go in a counterclockwise rotation past 180, somewhere in the third quadrant like there. So that's going to be 225 degrees. Now our related acute angle is that part of the terminal arm to the x-axis. So in this case, we went 180, and then how much further did we go to that terminal arm? Well, we went another 45 degrees. So again, I'm going to draw that terminal arm into a triangle, and see I've created one of those special triangles again. So I have a 45, 45, 90, and then we have to remember our side lengths for those. So 1, 1, and radical 2. But again, take a look where your triangle is. That leg of my triangle is on the negative part of my x-axis, so this is going to be a negative 1. And then we're going to have to go down for the other leg of my triangle, so this is going to be a negative 1. Because we are in the negative values of our x's and the negative values of our y's. Once again, our hypotenuse is always positive. So our related acute angle was 45 degrees. It says state the tangent of the related acute angle. So the tangent would be a negative 1 over a negative 1, which just equals a positive 1. So that is our tangent of 225. All right, take a minute to pause the video and try the third one on your own. So there's the solution for the last one. The sine of 300, if we were to draw that angle, that principal angle is going to end up in our quadrant 4. And then the related acute angle is going to be 60 degrees. So I'll make that terminal arm into a triangle, which would be our 30, 60, 90 triangle. And we'll label the sides that we know. And then we're going to find the sine of that 60-degree angle. So keep in mind, again, the one side length is going to be a negative radical 3 because our y values are negative there. So the sine of 60 degrees is a negative 3 over 2, and that will be true of the sine of 300 degrees as well. That is it for your note for today.